computer. All right, section 1.4, limits to infinity and infinite limits. So in this section, what are we going to learn? We are going to learn two things. So the first thing is limit to infinity, which is number one here. And second thing that we're going to learn is infinite limits, which is number two here. So for limits to infinity, it's going to be the case that you see this notation, x go to infinity or x go to negative infinity. This is the case that we say limit to infinity. So you're going to learn how to solve limit problem when you see this case. And after that, we're going to learn infinite limits. Well, which is the case that we have plus or minus infinity as our answer. All right, so we're gonna spend our first maybe 40 to 45 minutes on limit to infinity. All right, so let's look at the definition first. So let f be a function defined on some interval a infinity. So let f be a real value function that defined on some interval. Well, we're gonna say that limit of fx when x approach infinity equal to L. This means the value of fx can be made arbitrarily close to L by taking x to infinity. So what does it mean? Well, this notation means when x go to infinity, so the value of fx close to L, you can look at the picture here. When x go to infinity here, when x go to infinity, the value of fx just get close to L. Well, we don't care the behavior when, you know, where x come from, but we care where x goes to infinity. So when x go to infinity, we want to know the pattern of fx, that is limit of fx when x go to infinity. So note that the line y equal to L here that you see in the picture, this is called a horizontal asymptote. All right, this thing is going to be useful later when we trying to use derivative to plot the graph. After midterm, we're gonna talk about horizontal asymptote again and again. And also limit of fx when x go to negative infinity equal to L is defined in the same way. So just consider the case that x goes to negative infinity. So just the other way. That's it. That is how we figure out limit to infinity. Well, to compute limit to infinity, we have some theorems that you can use, and that will be useful to compute limits. All right, so let's look at that theorem. So first of all, before we look at the theorem, let's look at the function fx equal to 1 over x. This is the rectangular hyperbola, right? And the graph of fx equal to 1 over x is this graph, as you see in the picture here. This is fx equal to 1 over x. Well, you can see from the picture that limit of 1 over x, where x go to infinity, from the graph, you can see that when x go to infinity, the value of fx go to 0, right? So that's mean limit of 1 over x is 0 when x go to infinity. And also you know that when x go to negative infinity, limit of 1 over x. So look at the picture. When x go to negative infinity, well, the value of fx just goes to 0 as well. So this is equal to 0 as well. This is going to be handy and useful later, that you know that limit of 1 over x, either x go to plus or minus infinity, is equal to 0. And better than that, we have a theorem. Say that, well, limit of 1 over x to the r, where x go to infinity, equal to 0 as well for all positive rational number r. So for positive rational number r, we know that 1 over x to the r is equal to 0. Does it make sense? And also we also know that limit 1 over x to the r, where x go to negative infinity, equal to 0 as well, similarly. Well, when you compute the limits, when x go to infinity or minus infinity, you're gonna use this thing a lot, the diet box in green here. That is a theorem. So to look at the proof, you can see it in the textbook. Because we have time limit here, I'm not going to show you the proof, how to prove this theorem, but we're gonna use it to solve the problems. But well, I'm sorry that I cannot show you the proof now because, you know, because of the time limit. So if you want to discuss about the proof, you can make an appointment with me later so we can talk about the proof if you are interested. So let's look at the example first. So example 12, let's start from the basic. This is the one that some of you have learned in high school. So let's look at how to do it first. So I will write a full solution here. So make sure you look at my solution, and in order to get full credit on the exam, you should do, well, the way you write the exams, the solution should be the same or similar to what I am going to show you. All right, so here I see limit x go to negative infinity. If some of you know the answer already and answer 0 here, well, you get 0. Well, the grader gonna say, hey, did you just guess it? So what are we going to do is, well, I'm gonna say limit x go to negative infinity. First of all, I'm gonna copy the question, which you don't have to, but you can see that here I have x to the 4th power in the denominator. I'm going to divide it everything by x to the 4th power. This is the technique. Or I will tell you later. 3x cubed minus 7 over x to the 4th power. X to the 4th power minus 5x squared over x to the 4th power. And then after that, well, I simplify. So the first term is going to be, on the top, this is going to be 3 over x minus 7 over x to the 4th power, right? Because I just split it. And then after that, in the denominator, I have 1 plus 5 over x cubed. And then now by applying the theorem that we just discussed on the previous slide, you can see that every time when you see limit 1 over x to the r, where x go to negative infinity, this thing goes to 0, right? So this thing goes to 0, this thing goes to 0, this thing goes to 0. It is acceptable if you write something like this, go to 0, fine, you're good. And then after that, you can just say, hey, I use the limit law. And then I have 0 minus 0 over 1 plus 0, which is 0 over 1, which is 0. Done. Box your answer if need. Done. Well, this is the expectation for your solution. You should show your work something like this. Not just give the answer. It is
เรียนอย่างต้อง
unacceptable. You know what I mean?
ทำได้เสร็จแล้ว
All right. So if you understand this example, well, you can see my technique. So this is your technique that you can use later. So try to divide everything by the highest degree of x term, right? So this thing I see that I have x to the fourth power as my highest degree. So I divided everything by on the top and the bottom by x to the fourth power. The reason why I do this, you can observe that this is because once I divided everything by x to the fourth power, so everything will reduce to the form that I just cloud it in red here. So everything gonna turn to 1 over x to the r, and then we know how to compute limit of this thing, and that is easy, right? So everything gonna go to 0, and then hey, bam, you're done. So some of you have learned more than that. Some of you have learned something from the high school, which is a good technique. So if you see the rational function, this is the, how do I say, this is the tips. Well, if you see limit of the rational function like a times x, let's say x to the p, let's say a1 x to the p plus a2 x to the p minus 1 plus dot 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 over b1 x to the q plus b2 x to the q minus 1 plus dot 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 plus 2a m and bn. Let's say when x go to infinity. Well, if you see the rational function like this, rational function mean, you know, the fraction of polynomials. So you can compare p and q, right? So if your p if equal to q, then you expect that your answer, so the limit is going to be a1 over b1. This is your expectation of your answer, because if your p equal to q, it means your highest degree of the numerator and denominator, they are the same. So if you divided everything by x to the p, so the remaining term gonna go to 0, and then you have the first term only left. So that means you have a1 over b1. So in the case that you have p greater than q, then this thing your expectation for your limit is going to be plus or minus infinity, which we are going to learn later for this class. So for this case, you can think of the case that when you have something heavy on the top, when something heavy on the top, so it must dominate something at the bottom, and then after that, your answer gonna be plus or minus infinity. And then the last case, when you have p less than q, then your expectation of the limit is going to be 0, because this means the bottom is heavy. When the bottom is heavy, that means the bottom gonna dominate. And then once you have something that is heavy in the bottom, it's gonna dominate the numerator thing. And then after that, when you take limit, well, limit should be 0. So this is, you know, this is the rough guess that we can just guess the answer first. But when you show your work, you have to show your work like I start here. If you just answer immediately, not acceptable. And please don't cry if you say, hey, I can do it, but well, I get low score. Yeah, for sure, because you don't show your work. So if you want full credit or something like that, show your work fully as I show on this example. But well, I don't mind if you just guess the answer. It's just, you know, just a quick check in case that you wanna have so many technique with you, fine. But when you show your work, show full work, so the grader can grade your work correctly. All right, so we have 4 more example, I think, on this topic. So we're gonna keep going until 3:45, and we switch to another topic. All right. Any questions so far? Anyone? Type in the chat, please, if you have any questions. All right, so looks like everyone is on track. All right, so we're gonna do example 13. So one more on rational function. This question, it is not hard. It just asks you to to compute something about fraction, I think. So let's look at this question. So I'm gonna say this is limit x go to plus infinity. So I'm gonna simplify everything to the form that I like. So x to the 4/3, right? So this thing is going to minus 2x to the 1/2. And then this thing gonna be x to the x times square root x. This is x raised to the 3/2. And then that thing is x to the 1/3. Well, it's so ugly because you have so many fractions. But the key points are the same. You just need to find something that, well, the term that match with the highest degree. So 4/3, 1/2, 3/2, and 1/3. So seem like the biggest one is 3/2. So that means I am going to divide everything by 3/2. So my solution is gonna be x go to plus infinity, and then x over 3/2 over x over 3/2 plus x over 1/3, 3/2 here. So I'm gonna divide everything by x over 3/2. All right, and then after that, well, it's just all calculation. So now you can, the first one, x raised to the 4/3 minus 3/2. This is, God, I'm so bad at algebra, but I'll try. Make it 6 in the denominator. So that is 8/6 minus 9/6. So negative 1/6. All right, so that is x raised to the negative 1/6, and then minus 2x to the negative 1, right? And then this is 1, and then plus that is x to the negative 7/6. Okay, right? 6, 2 minus 9. Okay, good. And then after that, I have limit when x go to infinity. So you can see that I slow down because I'm not good at algebra. Well, if I make a mistake, just you can stop me, because x to the 1/6 here, and then minus 2/x, and then 1 plus x to the 1/x to the 7/6. All right. So the reason why I do this, because I want to see something that match with my form limit of 1/x to the r go to 0, right? That's why I swap x to the 1/6 to the bottom. So you can see this thing go to 0, this thing go to 0. So it's going to be 0 times 2, which is going to be 0 anyway. So this is going to 0 as well. So, well, at the end, 0 minus 0 over 1 plus 0, which is 0. You can see that this is easy and match with your intuition, because, well, the bottom is heavy because this is the highest term. This is the term with the highest degree. It is in the bottom, so the bottom is heavy. So I just told you that when the bottom is heavy, your limit should be 0. It matches with your intuition. So if your bottom is lighter, so you can expect your answer to be plus or minus infinity. And when they are balanced, so you can just use the coefficient, the ratio of the coefficient as your answer. All right, so we're gonna do more examples. So this is supposed to be the easy one. So number 12, example 12 and 13. So let's move to something more interesting, which is number 14. All right. So be careful about this example. Some of you think that this is easy and then you just, well, when you see square root sign, sometimes it is going to be tricky because you have to be careful when you take something out of square root. So the next two examples, I am going to show you the mistake that students usually make. So let's take a look at these two examples closely. So number 14 first. So here, if you want to guess the answer, so look, this is what you should do. So you guess your answer first. So the highest degree, this is 2. So the highest degree, this is 2, right? And x to the fourth power, actually we have to take square root. So it's going to reduce to x squared, right? Because this is x to the fourth power. And when I take square root, so the highest degree should be just degree 2. So now you can see that, hey, it seemed like the highest degree for the numerator and denominator, they are the same. So it balanced. So the answer should be the coefficient for the ratio of the coefficient. So, well, let's go. So we're gonna start by divided everything by x squared because that is our highest degree. All right, I'm gonna go slow as usual. The term that you have to be careful is going to be square root. Everyone gonna see in a minute. So x go to plus infinity here. And then now on the top, I simplify to be 2 plus 1 over x squared. And then on the bottom, I have 1 plus. So I'm going to go slow. So I'm going to just keep x to the fourth power minus x over x squared here. Because this term needs something that you need to be careful about it. All right. So the next thing is, well, what I'm going to do is, so I'm going to move this thing down. ไม่เหี้ยครับ limit x go to plus infinity. All right. We're gonna adjust something in the square root there. So I'm gonna keep everything on the top. In the bottom, we're gonna have 1 plus. Here, what I'm gonna do is I am going to pull out x to the 4 first. So I have x to the fourth power. And then I have 1 minus 1 over x cubed. All right, I hope you can follow. Right, and then after that, I am going to take my square root x to the fourth power. What is that? It is x squared, right? So I'm gonna have limit x go to plus infinity to plus 1 over x squared. And then 1 plus, well, I have x squared here over x squared square root 1 minus 1 over x cubed. And then after that, you can see that this thing go to 0, this thing go to 0, this thing cancel. So at the end, you have 2 plus 0 over 1 plus square root 1 minus 0, which is 2 over 2. This is 1. This is your answer. So the thing that you have to be careful is here, when I have square root x to the fourth power, so I say this is x squared. So keep in mind that square root x to the fourth power, this is square root x square square. And something square and then you take square root, this is absolute x square. Absolute x square is going to be x square or negative x square, depends on the value of x square. Right? We are lucky that this question, they ask us to do x go to plus infinity. Because they ask us when x go to infinity, and then x squared is always positive. So that's mean when you take absolute value, this thing gonna go to x squared anyway. Square root x to the fourth power is x squared anyway. So that's mean, hey, when you take square root x to the fourth power, it's just x squared. But it's going to be problem when, you know, sometimes when you see x go to negative infinity, something that when you take absolute value out and then you have to attach your negative sign, and then your answer going to be swap from plus to minus. Well, I will show you that case in example 15. All right, let's do that together. So this is the easy one because the sign doesn't change. But let's look at example 15. This is the one that usually students fall into the trap and then answer the wrong answer, because when they pull out something from the from the square root sign, they forgot to attach the negative number, the negative one. All right, so let's do this thing together. So limit of square root x square plus 4 over x plus 3. So you can see that, hey, I have x square here, and then I take square root. So the highest degree is 2, and then take square root is 1. So on the denominator, I have x here, which is the highest degree is 1. So you expect the answer to be the ratio of coefficient. But be careful. What you have here is x go to negative infinity. So let's simplify first. So what I'm going to do is, this is easy. So I'm going to just divide everything by x first. All right. So I'm going to clear the term on the denominator first. So that means 1 plus 3 over x. Well, denominator is easy. So on the top, I will pull out x squared. From that, I have 1 over 4 plus x squared. All right. And what should I do about square root x squared? Square root x squared is absolute x, which is going to be plus x or minus x, depends on the value of x. In this case, because x go to negative infinity, that means x is negative. So you have negative sign with you. That means when you do this thing, it's going to be limit x go to negative infinity. So you take square root x squared, and then you get negative x. Because x go to negative infinity. And then you have square root 1 plus 4 to the x squared, and then over 1 plus 3 to the x. Be careful about this thing. Here to here. Usually students make a mistake because they just forget to, you know, bring the negative sign out. And then after that, well, the rest is easy because this is 0. 1 second, I forgot over x. This move down. Oops. All right. Well, 1 second. Again. Oh, I forgot this thing. Over x, and then this, the whole thing 1 over 3 over x. Okay. And then now this x gonna cancel, right? And then after that, you have this thing go to 0, this thing go to 0, and then, well, it's time to compute. So this is negative 1 square root 1 plus 0, and then over 1 plus 0. So the answer is going to be negative 1. It looks easy, right? But, well, usually, well, don't go too fast because you have to be careful when you see x go to negative infinity and square root sign. All right. Feel better? All right, so let's do, I think, one more example. Yep, and then we're gonna go to infinite limits. So let's do example 16 together. All right. So example 16, let's do x go to negative infinity one more time. Well, this is harder than the previous one. So x go to negative infinity, but this time I have square root x squared plus 2x plus x. All right. So first of all, if I try to, you know, plug in negative infinity, so what should I have? So I have negative in, well, if I plug in negative infinity, I have negative infinity square. Doesn't make sense, right? And then plus 2 times and then square root, and then plus that don't make sense, right? Because you can see that, hey, under square root side, if you have something go to negative infinity square, here you're gonna get something positive infinity, and then you minus 2 negative infinity. I don't know what is the answer here. So anyway, it is impossible to plug in x equal to negative infinity there, because x equal to negative infinity is not a real number anyway. So the thing that we're going to use for this question, if you remember from last week, I said that if you see this thing, one technique that you can use is using a conjugate. If you remember, I said that if you see something like this, or maybe you use conjugate, right? Because it's going to simplify something, and then you hope for something that looks better for you. So here, what I'm going to do is I'm going to multiply conjugate first. So it's going to be limit x go to negative infinity square root x squared plus 2x plus x, right? So this is the original question. I am going to multiply by its conjugate, which is this thing. Well, make sure that you multiply by 1. So I multiply on the top and the bottom. And then after that, I simplify. So I'm going to get limit when x go to negative infinity, I have x squared plus 2x, then minus x squared. All right. And then over the denominator here is x squared plus 2x minus x. All right, looks better. I mean, at least in my eyes, because I think x squared gonna cancel, and hey, I have something that I feel better with, because on the top I have only 2x left, and in the bottom I have square root x squared plus 2x minus x. Looks better for me because, well, when it's reduced to this form, I have something to play with. So I can see that it's come back to a rational function. I mean, not just perfect rational function, because I have square root sign, but I have the ratio of some kind of polynomial. So that means I can look at my technique. So I have highest degree here 1 on the top. On the bottom, I have highest degree x squared take square root, so 1. So I expect the answer to be the ratio of coefficients. So what I'm going to do is I'm going to divide everything by x, because that is my highest degree. So it's going to be 2x over x. The bottom I'm going to have this over x. All right. And then now let's simplify a little bit. So the top I have 2. The bottom I have minus 1 here. So the term that I have to deal with is something over x here, which is square root. I'm going to pull out x squared first. That means 1 plus 2 over x. All right. And then, like the last question, I have square root x squared. So I'm going to say this is absolute x, which is going to be plus or minus, depends on the value of x. And of course, this is because this is x go to in negative infinity. So you have to use negative sign. So that's mean x go to negative infinity, and this is 2 times negative x, and then square root 1 plus 2 over x minus 1. All right, this thing cancel, this thing go to 0. So the answer is going to be 2 over negative 1 times square root 1 plus 0 minus 1. Let's hope that we have something nice. So 2 over negative 1 minus negative 1, which is negative 1, right? All right, sounds good. All right, that is limits to infinity and to negative infinity. All right, we did half of the work for today. So that is the first topic part for today. So I want to make sure that everyone can do this, because if it show up on the exam, well, limit is going to be the one that you should, you shouldn't lose your point because it is easy compared to differentiate and integrate. So make sure that, well, I go back to my theory first. So make sure that when we ask you to compute limit x go to infinity and limit x go to negative infinity, you can do it. Well, usually fx going to be given as a rational function, and then you can just use a technique that I just explained on page 25. So usually you can just guess your answer first by looking at the behavior of the highest degree. And then after that, you show your work in full by just divided everything by the highest degree and then follow the steps. All right. So I think we don't need a break. I think we can just keep going and then I'll let you leave early then. So let's move to infinite limits, another section. Well, yeah, I think we can just keep going, huh? And then we can just end the class at 4:15 or something. Maybe that's better for you. All right, so let's do infinite limits. All right, we have 44 students here. So for those of you who have not typed the check-in in the chat, type the word check-in in the chat because I want to know who attended the class. Just in case you are short 1 point to grade B plus or something like that, so I can help you because you attend the class. So type the check in the chat. So this is my the way to check that you attend the class. Well, I mean, I monitor you. I mean, if you leave, well, I monitor the number now. It's 46. All right, sounds good. All right, next we are going to do infinite limits. All right, consider the graph first. So again, infinite limit is not hard, but you need to know how to show your work, because if you don't show your work as we expect, you're not going to get full credit. All right, so let's look at this graph first for infinite limits. So I am going to look at the behavior at x equal to a. So let's look at the behavior at x equal to a. At x equal to a. So you can see that when x go to a from the left, this is my notation, right? When x go to a from the left, what happened? Follow the line that I have in purple now. So when x go to a, you can see that the value of fx increase, right? Without n. So it just go up and up and up and up to plus infinity. So this is the case that we're gonna say limit of fx when x go to a from the left, this is equal to plus infinity. So it is possible that your answer when you have when you compute the limit, it's going to be plus infinity. Similarly, if you look at the behavior on the right hand side of a, so you're gonna see that the graph just go down without n. So that's mean limit of fx when x go to a from the right. This is negative infinity. So it is possible that the answer when you compute limit is going to be plus or minus infinity. Well, keep in mind that when we say limit is equal to plus or minus infinity, technically the limit does not exist. Oh, the limit does not exist. So this is the thing. We say that limit exists when the limit is a real number. If the limit is not a real number, we say limit does not exist. So infinity and minus infinity, they are both notations. So they are not a real number. I mean, they're not real numbers, sorry. That means this is the case that limit does not exist, but we know the pattern that it does not exist because it's go to infinity or it's go to negative infinity. Does it make sense? Well, I will repeat again. So when limit is equal to plus or minus infinity, we say that limit does not exist. It's just one case of does not exist. So limit go to plus infinity, limit go to negative infinity. Well, so let's first look at the graph. So this used to be your O exams. Well, we're gonna do this thing very quick to check if you understand the behavior at infinity. All right, so let's do this thing quick together. We have 3 examples here. So I think it's supposed to be super easy, but well, hope we can pass this thing very fast. All right, so first, number 17. Fill in the blanks. So if the limit does not exist, state whether it is infinity, negative infinity, or does not exist. So it's all does not exist, but does not exist in the last case. It means the left hand limit and the right hand limit are not equal to each other. Left hand and right hand limit are not equal to each other. All right, so let's look at the first one. So when x go to negative infinity, so what is the behavior of f? So you can see that, hey, when x go to negative infinity here, when x go to negative infinity here, so the one that I draw the line in the picture, so you can see that this is plus infinity, right? And then when x go to plus infinity, this is 0. But just looking at the graph, limit when x go to 0 from the left, right? X go to 0 from the left, this is 1. Limit when x go to 0 from the right, what is that? Negative infinity. Well, answer in your mind and then check if it match with my answer. It should match. So limit when x go to 0, because on the left hand side I have 1, on the right hand side I have negative infinity. So that means this does not exist. This is because the left hand limit and right hand limit are not equal to each other. Well, actually the right hand limit does not exist already. So next I look at the behavior at 2. So limit from the left is 0, limit from the right is negative 2. So this is the and limit at x equal to, when x approach 2 is also does not exist because the left hand limit and right hand limit are not equal to each other. So this is example 17, supposed to be easy. All right, so 18. So let's do one more. Limit when x go to negative 4 from the right, which is here, which is also what number 6. Some of you gonna say does not exist because, hey, Ajahn, at x equal to 4, I don't have, at x equal to negative 4, I don't have the left hand limit. Well, you don't have to think about the left hand side of negative 4 because the domain is negative 4 to 0, union 0 to infinity. So this is out of domain. So on the left hand side of negative 4, this is out of domain. We don't, well, when the domain does not, you know, intersect with the left hand limit, you don't have to care the left hand limit. The limit is going to be just the right hand limit. All right, so after that, well, limit when x go to negative 4, fx is equal to 6 as well. Well, because the domain is just negative 4 to and up, negative 4 to 0 and 0 to infinity. And then limits at x go to 0 from the left, this is negative infinity. And then limit x go to 0, well, this is also negative infinity, right? Because both left hand limit and right hand limit, they just go to negative infinity. And then x go to 2, So this is easy. So 3, 4, and does not exist. And then the last one, limit go to x go to plus infinity. This is 0. All right. Well, for the fill in the blank question like this, well, super easy. So I trust that everyone can do this thing. So if not, email me. So we need to talk. So you need a tutor maybe. I mean, if you feel like, hey, this is so hard, well, we need to talk because your background is so weak. So maybe you need a tutor and then I can help you. All right. So uh example 19. All right, so let's look at this one. This is a little bit challenging in terms of when they ask something, they just don't do the fx, but they just do some, transform of fx. So the first one, limit of x go to -1 on the left. So let's do -1 on the left. This is -1. X go to -1 from the left. This is equal to -1, right? But you have to multiply by 3. Well, technically you can pull number 3 out because limit laws, and then you can just multiply number 3 to number -1 later. So this thing is going to be -3. And then after that, well, the next question, you have limit of fx when x go to -1 from the right, which is here, but I just draw it in green. So this is going to be number 1, right? And then you have to add 1 later. So it's going to be 2. Because the limit of constant is just that constant. And then when you ask limit when x go to -1, so well, this does not exist because you can see from the picture that left hand limit and right hand limit are not equal to each other. And then let's look at limit when x go to 4. Well, this is plus infinity, right? Because both go to infinity. And then the last 2 questions, so this is so boring, I know. So the last 2 questions, when x go to plus infinity, well, this is 0. And then too easy, not just boring. 1 over fx. So this means, well, you see when x go to plus infinity, x go to negative infinity, so x go to the left here. And then you can see that limit fx when x go to negative infinity, this is negative infinity from the picture. Well, that's mean if you do 1 over f, this is 0 because it's 1 over infinity, right? Swap 1 over something big, this is just 0. All right. Any questions on looking at the limits from the graph? Well, on the homework questions, what they ask you is you're gonna get the condition of limit here. This is on the homework. Homework question 1, you're gonna get this thing. And then they're gonna ask you to sketch the graph. Of course, the answer is not unique. There can be many solutions that match with the condition here. But they ask you to draw a possible graph if you have the condition like this. So try to do that question. It's going to be your homework number 1, which is due next Monday. So homework number 1 is going to be ask you to draw the graph from the condition, from the limit conditions that you are given, and then also show your work for computing the limits. All right, so let's look at the last topic for today, and then we're gonna just keep going until we hit the last example of this topic, and then that's all for today. So the last topic for today is you already know how to figure out infinite limits. So let's see how we show our work formally. This is what you're supposed to do. All right, we have the theorem. Well, to show your work, to show that limit when x go to something, it's equal to plus infinity or minus infinity. We need to show 2 steps. If you don't show these 2 steps, it is not acceptable. So number 1, we need to show that limit of 1 over fx, where x goes to this thing in the box, whatever it is equal to 0. First, you need to show that the reciprocal, the limit of the reciprocal thing, 1 over fx, this is going to be 0. And then second, you need to show that for x go to that number, whatever it is, if fx go to greater than 0, if x is positive, then limit fx is going to be plus infinity. This is how you conclude. And then for x go to that number, well, if your fx is negative, then your limit is going to be negative infinity. Well, the key idea here is we're going to show first that the limit of 1 over fx is equal to 0. And then after that, we're going to look at the behavior near the rectangle here. If near the rectangle, you know that fx is positive, so you're going to answer plus infinity. If you know that near the triangle here, not triangle, rectangle here, fx is negative, so you're going to conclude that the limit is negative infinity. This is how you do it. You need to show 2 things. If you don't show it and then you answer plus or minus infinity immediately, no credit. All right, so I have 5 examples lined up with me now. So we're gonna do this 5 example maybe in 15 to 20 minutes, the remaining time, and then we're done for today. All right, so let's see how it works. So they're all easy. So let's do the first one. Limit of 2 plus 3x over 1 minus x squared to the 4th power. All right, so to complete the question, so let's think first. Well, if you try to plug in number 1 into the limit, right? So you're gonna get 2 plus 3 times negative 1 over 1 minus negative 1 squared to the 4th power. If you're trying to plug in, you're gonna see you get some number on the top, and then the denominator you get 0. Well, in the case that you get something, some real number that is not equal to 0, over 0, so you can expect your answer. Expected answer, this is going to be plus or minus infinity. This is your expected answer. But you cannot just say, hey, Ajahn, I think the answer is going to be plus infinity, and then you answer it. This is not acceptable. So the thing that we're going to do is we're going to show your work by using the previous theorem. So this is what we should do. So we're going to let fx to be 2 plus 3x over 1 minus x squared to the 4th power. So this is your first example. So I'm going to show your work fully. So condition number 1. So I need to show that limit of 1 over fx equal to 0. So I consider limit of fx where x go to negative 1. And this thing is going to be limit when x go to negative 1. Oh, sorry. I need 1 over fx. Right, and that thing is going to be 1 plus, minus x squared to the 4th power over 2 plus 3x. And then after that, well, this is easy because if I use limit law, it's going to be 1 minus 1 squared to the, here, 1 minus negative 1 squared over, to the 4th power, 2 plus 3 minus 1 here. And that is 0 over negative 1, which is 0. Here we go. I'm done with condition number 1. Does it make sense? So in order to show limit go to plus or minus infinity, you have to show 2 things. So I just did number 1. So I need number 2 now. All right. So how do I do number 2? So let's see. Number 2. So let's consider. So I want to know if x is positive or negative when x approach negative 1. First of all, let's consider 1 minus x squared to the fourth power. This is always positive, right? No matter what, something raised to the fourth power is always positive, right? And then, well, 2 plus 3x, this is less than 0 when x is close to negative 1. Let's say negative 1 is the value that close to negative 1. I say this is going to be negative 1, 0.00001. And then on the left hand side of the interval here, I'm gonna use something that is a little bit, well, so let's do the easy one. So negative 1, 0.01, I'm gonna add 0.01 here, and then I'm gonna minus 0.01 there. So this is going to be, well, this is negative sign, sorry. All right, that's all right. Oh, okay, I'm good now. Sorry. So when x close to, this is when x close to negative 1, right? When x get close to negative 1, it means x is coming close to negative 1. Well, that means I can pick any x in between negative 1.01 to negative 0.99. This is going to be the number that is close to negative 1. And then if I pick the number in this interval, and then I plug into the number 2 plus 3x, right, to the function here, 2 plus 3x, I get negative number. Well, if I combine everything together, so I have fx equal to 2 plus 3x over 1 plus x squared to the fourth power. Well, this is going to be less than 0 because on the numerator I have something negative. On the denominator I have something positive. And then the ratio must be negative. So from 1 and 2, we conclude that limit of fx when x go to negative 1, this is equal to negative infinity. Again, to show that the answer is plus or minus infinity, two things. Show that limit of 1 over fx is 0. Next, show that fx is positive or negative when x get close to that number. Well, you can pick whatever you want in the box here, but just pick the one that is close to negative 1. All right, so let's do more example, and then you're gonna see, well, once you pass more example, you're gonna see, hey, make more sense in terms of computing limits. So it's gonna be a bit harder and harder. So let's look at example 21. All right, so first, well, when I see this thing, first of all, I want to factor because, well, I see the denominator and then I want to factor so bad. So I'm going to factor first. So x plus 7. So on the denominator, I have x squared times x squared minus 49, right? And then I say, hey, x squared minus 49, I hate it. So it's going to be x plus 7 times x squared, x plus 7, x minus 7. All right, something cancel now. Good. I feel better. And then now this is going to be limit of x go to 7 from the right of 1 over x squared times x minus 7. Well, when you have something like this, so you expect that. So you expect that your answer gonna be plus or minus infinity. Right? Because This is because your denominator go to zeros and then your numerator just 1. So I'm gonna let fx to be 1 over x squared times x minus 7. And then condition number 1, I'm gonna consider limit 1 over fx, where x go to 7 from the right. And this thing going to be limit of x squared times x minus 7. X go to 7 from the right. Well, this is completely 0 for sure. All right, good. All right, good, 0. I'm good now. And then next, number 2, I need to figure out fx equal to 1 over x squared times x minus 7. This is going to be what? Negative or positive? I mean, greater than or less than 0. When x get close to 7 from the right. When x get close to 7 from the right, so what is the sign here? Greater than or less than? Type in the chat, please. Now, if you are with me, this is a double check that you still with me. So type in the chat that you're gonna pick greater than sign or less than sign. Some of you say greater than. All right. Seem like everyone just goes in the same way, greater than. All right, sounds good. So greater than. Someone type in Thai so they don't change the language. Okay, so greater than 0. So that means your answer gonna be what? So we conclude that, well, limit of the given problems here, this is plus infinity. Well, the sign plus or minus infinity is gonna depend on this thing, the one that I highlight in light blue. If this sign is less than, so you're gonna answer negative infinity. If the sign is greater than, you're gonna answer plus infinity. Does it make sense? You have to show your work like this, 2 conditions. If you skip this thing and then you answer plus infinity immediately, well, don't cry if you get low score on the midterm exam, because, well, at least if I am a grader, I will not give you a credit because you don't show your work. All right, next, number 22. So I think we can do 2 or 3 more examples for 10 minutes. So let's trying to do more. So we should leave on 4:15. I think that's the good time to leave. So let's do example 22. All right, example 22. All right, so let's look at this thing. All right, I think it's not that hard. So we're gonna let fx to be x minus 2 over x minus 1 cube. All right, number 1. So I know immediately that the answer is gonna be plus or minus infinity because, well, I have 0 on the denominator and then on the top, if I plug in 1, I get something that is not equal to 0, right? So what I'm gonna do, I'm gonna do this first and then x go to 1 of 1 over fx. And then this is limit of x go to 1 of x minus 1 cube over x minus 2. And then that is 0 over 1 minus 2, which is 0. All right, good. Number 2. Limit when x, I have to figure out the sign of fx when x approach 1. So what are you going to use? Plus, greater than or less than. This is hard. So let's look at this thing. When x go to 1, can you say 100% that the sign gonna be greater than or less than? So first of all, x minus 1 cube the sign of x minus 1 cube, this is going to be the same sign with x minus 1, right? All right, so let's look at this thing. So when x, let's start by when x is in the range 1 and 1.1001. This is from the right. If x is a little bit bigger than 1, so what happened? If x is a little bit bigger than 1, x minus 1 cube is going to be positive, right? If x is a little bit bigger than 1, x minus 2 is going to be negative, right? And then negative over positive, so this is negative. Well, this conclude that limit of fx when x go to 1 from the right, this is negative infinity. So another line, I have fx equal to x minus 2 over x minus 1 cube. Well, this time I'm gonna do x go to 1. Let's do 0.999. I just go to 1 from the left now. So if it is this case, so what happened? On the top, I have x minus 2, which this thing is going to be something below 1, negative 2, so negative. And then x minus 1 square. This thing is something below 1. You cube it, so you still get negative. So negative over negative, so this is positive. So this conclude that limit x go to 1 from the left of fx equal to plus infinity. And then what happened with your real answer here? So conclusion. So your limit of x minus 2 when x over x minus 1 cube when x go to 1. This does not exist. Because your left limit is plus infinity, your right limit is negative infinity. So it does not exist. You cannot say immediately that this is going to be, you cannot say that limit when x go to 1 is going to be plus infinity or minus infinity, because, two-sided, they're not the same. So this is a good example, actually. All right, so let's do more example. Hopefully you feel better and better when we do more examples. So I think maybe this is the last one for today. And then, well, we can start example 24 on the next class, I think. All right, so, well, let's see the time first. Okay, example 23, evaluate limit when x go to 6 cosine x over x minus 6 square. All right. Well, someone see cosine here, and someone, maybe you are trying to use the, how do I say, the squeeze theorem, right? But it does not work, because if you use squeeze theorem, so let's see what happened. I mean, if you use squeeze theorem, well, some of you, maybe you're gonna try use squeeze theorem. All right, and then that, let me try. Does it work for squeeze theorem? And then you take limit. Well, no, the squeeze theorem does not work, because if you take limit on the 1 over x minus 6 square, so you should get, does not exist, right? Oh, no, it's a plus. It's always, so if you use squeeze theorem, so you're gonna end up with the cosine x, limit of cosine x over x minus 6 square is in between negative infinity and plus infinity. It does not help at all. So the squeeze theorem does not work, because if you use squeeze theorem, you're gonna find out that this thing 6 is positive. infinity, and this thing is negative infinity. So it does not work because they are not real numbers and they are not equal to each other anyway. So the squeezing theorem does not work. So you have to figure out by using other technique. And of course, because we are learning infinite limits now, so we are going to use the one that we just did on the previous example. So we're gonna let fx to be cosine x over x minus 6 square. All right, and number one, I'm gonna try to compute limit 1 over fx. All right, so here we go, x minus 6 square over cosine x, and then you evaluate at 6, 0. Good. All right, so number two. So I have fx equal to cosine x over x minus 6 square. Well, I need when x get close to 6, let's say 5.99 and 6.01. So what happened here? Plus or minus. All right. So of course, I mean, in the denominator here, this is always positive, right? Well, you have to figure out cosine x here. So what is the value of cosine 6? So 6 here is not a degree. When I say cosine 6 here, this is radian. So what is the cosine 6? If you remember from trigonometry basic. All right. Well, pi is about 3.14, right? 2 pi is about 6.28. So if you are looking for cosine 6, it's going to be something that fall into the fourth quadrant. This is 6 radian, right? Because 2 pi gonna be the x-axis here. This is 2 pi, which is 6.28. And you just have 6 radian, which belong in the fourth quadrant. So when you have something in the fourth quadrant, cosine 6 gonna be positive, right? Because on the fourth quadrant, so cosine is positive. If you remember, right? Because I mean, when we learn trigonometry, so this is all. This is sine, right? This is tan. This is cos. Add sugar to coffee. All students take calculus. Whatever you learn, I mean, in high school, all students take calculus. Add sugar to coffee, whatever. But anyway, the 6 radian is in quadrant number 4, so cosine must be positive. So this thing is positive, and then your answer conclusion is gonna be limit. This is your summary. To sum up, limit of cosine x over x minus 6 square, where x go to 6 here, this is plus infinity. All right, and that is the end for the lecture today. All right, any question before you leave? Sounds good. All right, if you have any question, email me, or you can make an appointment with me anytime. And well, have a good evening, everyone. And the clip will be posted, well, 1 or 2 days after the class. And also we're gonna meet again on Friday, not Wednesday. This Wednesday, I have a conflict again. So just this week, and then we're gonna meet again Friday on 8 a.m. And then, well, next week is gonna come back to Monday, Wednesday at 3 p.m. All right, thank you for attending. So if you don't have any questions, so you can go. I can go. All right, thank you very much.